Hello everyone, welcome back. Before you start this tutorial, please complete the previous tutorial on how to train your machine learning models. And then once you have completed this, then we can move on to how to use a pre-trained models to make predictions. So before we start here, make sure that you have your trained models and your best model selected from in the best model folders. And now the next step is that we need to apply these models to our future street themes. In this case, I have given a sampled 300 points from Hong Kong as an example. You can swap in your own sample points from your own district into this file. So in this file, it needs to contain, of course, a longitude, latitude, and there are a few things that we don't need, but most importantly, the image segmentation outcome from here. So for example, the percentage of trees, percentage of the road, percentage of the plants, and it needs to be in the default name. By the way, we only use the image segmentation outcome instead of image detection outcome for the following reasons. First of all, by the time I record this video, I did not have enough time to conduct the instance detection, which is a mask RCN on all of them. And also, additionally, sometimes there's a big problem with that because if you want to make predictions based on humans and the cars, sometimes the street view images only capture at a certain time of the day, and it doesn't sufficiently describe the overall general quality of the space. However, it's valid to inform design decisions. For example, say more people there are, the better feeling of safety there are, or better feeling of richness there are. So that's all possible. But just in this case, we're not using the people counts and the car counts. In any of the scenario that you do want to use the people's counts and car counts, personally, I find that will significantly increase your prediction accuracy, which is your R-squared values. If you want to use that, you have to retrain your models. Basically, in here, no, sorry, not in here. In the model training label part, you have to add the column names for the people's count. For example, in Berlin categories, Berlin continuous, the people's count, they're named as the city number. So we have to add those columns like count person, count bicycle, count cars, count motorcycle, count trucks. Personally, it will significantly increase your predictions. The more features you put in, the better prediction is. So if you want to include your mask RCN instance detection results, please put the name of the columns in the model training here, and just attach them to here. For example, you can also add, let's say, here is the city car. Yeah, and so on. Just put all the column you want to use to make a prediction here to retrain your model. But remember, once those columns are included in the models, they have to be included in your in the context you're trying to predict. For example, I can't do that because currently in my Hong Kong tools 300 data set, I don't have those car counts and the people's count. So I did not train the model based on the car count and the people's count, and I will not use that one for prediction as well because I don't have that information. But feel free to use it for your own predictions and train your own version of models. All right. In any case, so our Hong Kong site we have done all the image segmentation and have all the percentage of the skies, roads, sidewalks, trees, earth, and etc. Our goal is to make prediction on its Q score in terms quality score in terms of richness, scales, orderliness, enclosure based on those, even though we have never done any statistic on this, never done any survey on this, but we're going to use a model that we trained based in Berlin to predict Hong Kong. So first of all, we get our CSV file, including all the right categories, and we identify what are the columns that we're trying to use to make the prediction. So we'll not be using the rental price, housing price, distance to city center. We'll be making a prediction purely based on the street view images. And then we read the models. So we read the ecological models, the enclosure models, the scale models, or you can add a few more of models for your choice. So we add them from the, let's say, our best model set. In case this one is actually read from the train model set, but I do give the name of each of the models. So now once the data sets are read and the models are loaded, it should not return any error. And the code making prediction is very simple. If you're only making one prediction, you only need one line for this. And because I'm making 3 predictions on both ecology, enclosure, and scales, I'm having 3 duplicate line of this. You can customize this one to fit your own prediction goals. Even though we do have a few models that have very low R2 that we did not put them into our best models, but feel free to apply them, it doesn't hurt. And sometimes it does capture certain patterns in that. It's just that the data sets may also be influenced by other factors that are not quantified in our Excel sheet. For example, see like people's counts, car counts, and etc. that we did not include in our prediction. But it's still enough to see a general pattern. So feel free to insert other model here to make prediction on other qualities. But in this case, we're just going to predict on these 3. And it will generate a file called Hong Kong 300 combined score. So once clicking this, now it has 3 new categories of enclosure, ecology, and the scale. So those are the prediction based on the models that we have trained. Now, even though we have never been done any survey on Hong Kong, but this is able to apply the knowledge it learned from our Berlin exercise and make a prediction on the perception of the qualities, perception of enclosure, perception of ecology, and perception of scales on our Hong Kong site. So for those of you who have done Mapbox tutorials, feel free to download this and quickly insert it into Mapbox and to see the distribution of the points and their related scales across Hong Kong. Or you can also put this one into your GIS or Grasshoppers to allocate this in our Hong Kong context and see the quality of space changes across different contexts and locations in Hong Kong. So essentially, this is the full process of training your model, prediction, machine learning models, and how to apply your machine learning models to other contexts. Of course, you can use our own statistic data. So I think we will clean up the work from home surveys and make that one another side of pre-existing data set. So feel free to apply the things we have learned in those tutorials to our other statistic data sets and etc. Of course, for your own design analysis process, feel free to apply this model. So this one already have scores of, this one should already have scores for, let's say, order, aesthetic, access, ecology, enclosure, richness, and scale. It should be also already able to score those qualities to your own district of selection. So please try to apply this one to this model to your new context, as well as trying to train your own model based on other survey outcomes. Thank you very much, and I hope you enjoy the contents of this week.